Folks, what's up? So in this video I'm gonna start a new chapter of ncert physics class 11. This is chapter number 11 of ncert physics class 11, thermal properties of matter. Okay, so let's start this chapter. Okay, let's first see which topic we have to cover in this chapter. First we'll see the introduction paragraph, then we'll see temperature and heat, the second paragraph. Then the third topic will be measurement of heat. Okay, then we'll deal with ideal gas equation and absolute temperature. Thermal expansion will our next topic. Then specific heat capacity, calorimetry, change of state, heat transfer, and lastly we'll do Newton's law of cooling. Without wasting any time, let's jump to the introduction paragraph. Okay, so now I'll explain ncert line by line to you. Okay, so stay tuned. So now let's begin. Just a second. Okay, so in this introduction paragraph it is given that we all have common sense notion of heat and temperature. Okay, we all know what heat and temperature is. We have been studying about heat and temperature from our lower classes. We know heat is kind of energy, the form of energy. Okay, we all know that it flows from hot body to cold body. And temperature, we know, like two bodies are there and we'll say that one body is hotter and the second body is colder. We kind of make a comparison between the two, and that is a determinant of physical quantity we use to differentiate between the hot and the cold body. And we'll say the temperature of the hot body is more and the temperature of the cold body is less. So temperature is a measure of hotness of a body. Okay, how hot a body is, okay, that is temperature. A physical quantity which tells us differentiate between a hot body, a cold body, a hotter body. A kettle with boiling water is hotter than a box containing ice. Okay, definitely there is a kettle and there is a warm water in it. It is hotter, and a box which has ice in it, it will be colder. In physics, we need to define the notion of heat, temperature, etc. more carefully. In this chapter, you will learn what heat is and how it is measured. So what we're gonna study in the chapter? What is heat? We'll go in depth of this. And we also see how it is measured. The measurement of heat, it has a term calorimetry. Okay, so that we'll study, and study the various processes by which heat flows from one body to another. What are the processes? Convection, conduction, radiation. Okay, along the way you will find out why blacksmith heat the iron ring before fitting on the rim of a wooden wheel of a bullock cart. Okay, so you see blacksmith, they have to put an ironing around a wooden wheel. Okay, so what gonna do? They're gonna warm it to certain temperature that it expands. The iron is almost the size of this wheel, but they warm it to a very high temperature, and you will learn later that it expands. Solids have a property that when they are heated, it expands, their volume increases. So now they left the iron around this wheel and they let it to cool down, and when it cool down, then it just fits the size of the wheel, and that's how the blacksmith is able to fit the that iron part around the wheel. Okay, so now this is one thing I'll explain it to you, and that we have to also study later, then when we listen there's a thermal expansion of solids. Okay, thermal expansion of matter. And then there's another thing that is mentioned under the phenomena, that is, and why the wind at the beach one reverses direction after the sun goes down. So it happens in the coastal region. that the sea breeze or the land breeze, they are given the name. So how does this phenomena occurs, we'll study later in the chapter. You will also learn what happens when water boils or freezes, and its temperature does not change during these processes, even though a great deal of heat is flowing into or out of it. So when water changes to steam, or even the ice changes to water, basically there's a change of state. So we are giving it heat, and even though we are giving it heat, the temperature is not changing. Where the heat going? We'll find out the answer of this. You already know this question. Maybe you have already read in lower classes, but still, we'll go in more depth in this chapter. Okay. Then let's move now again. So we will do the second paragraph now. This is article number 11.2, and this is temperature and heat. We can begin studying thermal properties of matter with definition of temperature and heat. So we'll first see the temperature definition. Temperature is a relative measure or indication of hotness or coolness. Very common definition we have been reading from our lower classes. Temperature is the degree of hotness or coolness. Okay, and it is a relative measure, that is, we are comparing two bodies. A body, there are three bodies, A, B and C. Body A is at like C, there are three bodies, so this body B is hotter than C. So it might be possible, it is possible that B is hotter than C, but as compared to A, it is colder. Okay, so temperature will give us a fair idea. It will assign a number to it. How much? You are saying that this body is hotter, but how much? A hot utensil is said to have a high temperature, and ice cube to have a low temperature. Okay, very obvious thing to understand. An object that has a higher temperature than another object is said to be hotter. Okay, so again it's very clear, like an object having a higher temperature will be hotter. Okay, and or even we can say it opposite, like if there is a hot body, definitely its temperature is higher. Note that hot and cold are relative terms, like tall and short. We can perceive temperature by touch. Okay, so these are relative. I already told you. By touching, we can perceive temperature. Okay. However, this temperature sense is somewhat unreliable, and its range is too limited to be used for scientific purposes. What is this? We'll see now. Now, we know from experience that a glass of ice cold water left on a table on a hot summer day eventually warms up, whereas a cup of hot tea on the same table cools down. Okay, you have experienced this. We all have experienced this, like ice cold water. Okay, in summer we keep our ice cold water outside, and what we see after some time, oh no, it's not that hot, it's not that cold, it was chilled when we have taken it out of the freezer, but now no, it start melting, and by and by its temperature start coming to the room temperature. Whereas a hot cup of tea, okay, it's very warm, we have to wait for a while to drink it, but after some time it's become lowering its temperature. The temperature start going down, and after some time it's come to the room temperature. It means that when the temperature of body, ice cold water or hot tea in this case, and its surrounding medium are different, heat transfer takes place between the system and the surrounding. Okay, so there are one is a system, like in case of that ice cold water, that is our system, and then the surroundings elsewhere around it is the surroundings. So whenever there is a difference in temperature, heat start flowing. Okay, so heat when heat start flowing, when there is a temperature difference between the system and the surroundings. And until when this heat will keep on flowing, until or unless temperature is become same, the system and the surrounding temperature comes to a constant value, they become same, equilibrium is stabilized, then heat will stop flowing. So heat will keep on flowing from the system to the surroundings whenever there is a temperature difference. Okay, so then we also know that in the case of glass tumbler or of ice cold water, heat flows from the environment to the glass tumbler, whereas in the case of the hot tea, it flows from the cup of hot tea to the environment. Very obvious thing again. Heat flows a hot cup of tea, it has very high temperature. Suppose I say it has 100 degrees Celsius and the surrounding is maybe 30 degrees Celsius. So what will happen? Heat will flow from the cup of tea to the surroundings. Whereas in case of a glass tumbler with as ice or ice cold water, okay, so it has lower temperatures, it 0 degrees Celsius. So heat will definitely flow from the surrounding, which is, as I told you, 30 degrees Celsius. It will flow to the glass tumbler. So now we can define heat. Heat is a form of energy transferred between two systems. So it can flow between two systems or a system and its surroundings by virtue of temperature. Very important line. When heat flows, when there is a temperature difference. The SI unit of heat energy transfer is expressed in joule, while SI unit of temperature is Kelvin. Okay, so you have to remember this SI unit. You must know this. You already we have studied in the lower classes. And degree Celsius is a commonly used unit of temperature. When an object is heated, many changes may take place. Its temperature may rise, it may expand, or change state. There are a bunch of things that's happening when we heat a body. Temperature rises and state changes. And we'll see about this now in the next paragraph. So the next paragraph is about the measurement of temperature. Let's move to this paragraph and start reading it. A measure of temperature is obtained using a thermometer. So how do we measure temperature? We all know there's a device called thermometer. Many physical properties of material change sufficiently for temperature. Okay, so there are a lot of physical properties. Like one we'll study now is the volume. Volume for liquid changes when we heat a body. Okay, like thermal expansion we study later in this chapter. We'll see that when we heat a body, its volume changes, it expands. Similarly, yeah, this volume also changes when we heat even in case of a liquid, there is a variation, it expands. Not all liquid expands, some are exceptions, there are exceptions, and we'll study about those exceptions also. A normal expansion of water is there, 0 to 4 degree, it shows a different behavior, but most of the cases it expands. And we use this property for the designing a thermometer, the liquid type thermometer. So what happens, like the liquid inside the thermometer, in a liquid mercury type thermometer, when we put the thermometer glass tube, that part to the patient's body, okay, so the body temperature is a little higher, so it will shoot up. The volume of the mercury will will increase, it will shoot up, and we can calibrate it, and we will find that it will show the temperature of the body. Okay, so this is the one parameter we have set with the temperature and heat. The volume increases, the physical property changes. Thermometers are calibrated so that a numerical value may be assigned to a given temperature. Okay, so they are calibrated so that a number can be assigned to it. Like in the case of our body, it is in degrees Celsius scale, it is 37 degrees Celsius. We assigned a number at that particular temperature. For the definition of any standard scale, two fixed reference points are needed. Okay, so for a standard scale, like we'll see there are three or four scales of temperature. Fahrenheit scale is there, Newman scale is there, and degree Celsius and Kelvin scale. So for that, two reference points are needed. Okay, since all substances change dimension with temperature, in absolute reference words expansion it was available. Okay, so all substances change dimension with temperature, so absolute not available, but however the necessary fixed point may be correlated to physical phenomena that always occur at the same temperature. Okay, so there is a change, there is a lot of variation, but there are certain things, certain properties which occurred exactly at the same temperature. Like we'll study about the triple point, even melting and boiling point is there. Okay, melting and boiling point, but we'll see that with impurity it's not a good option, but still for discussion now, it is the ice point and the steam point of water are two convenient fixed points and are known as the freezing and boiling points. Okay, so yes, ice point, that is the melting point, and steam point, that is a boiling point of water. They are fixed for water, pure water at least. They are fixed 100 degree and 0 degree Celsius particular temperature. So we have taken two reference points, a temperature where where water freezes, it is always fixed, so we have taken that is 0 for a degree. I'm talking about the Celsius scale. And for the boiling point of water, steam point, we assign a value 100 degrees Celsius, and 100 and 0, we will say that there are 100 temperature, 100 scales can be made between them. Okay, and we assigned 100 values in between. This is one criteria. Similarly for Fahrenheit, what we did, the boiling point is 212 degree Fahrenheit. Okay, we put what Fahrenheit did, we put this. He said that yeah, this is this temperature, there is boiling point, and 40 degree, if I'm not wrong, or minus 40, somewhat it is somewhere here. So he said, okay, this I got two reference point, now I'll make 180 lines in between, and he assigned the temperature there. Okay, so now the two familiar temperature scales are the Fahrenheit temperature scale and the Celsius temperature scale. The ice and steam point have values 32 degree. Okay, that's what 32 degrees Celsius. I'll correct myself. That was not 40 degree Fahrenheit. That is 32 degree Fahrenheit and 212 degree Fahrenheit respectively on the Fahrenheit scale, and 0 degree and 100 degree on the Celsius scale. On the Fahrenheit scale, there are 180 equal intervals between two reference points, and on the Celsius scale, there are 100 reference points. There is a graph given of Fahrenheit temperature and degree Celsius in Fahrenheit. Okay, this is a straight line you can see. Okay, as degree Celsius temperature increases, also in Fahrenheit temperature increases. You can see here, this is 212 is the boiling point of water, and this 32 is the melting point of water. This is Fahrenheit. In degree Celsius you see 0 degree and 100 degree for 212. A relationship for converting between the two scales may be obtained from a graph of Fahrenheit temperature versus Celsius temperature in a straight line. Okay, so from that graph we can obtain an equation here, and it is very helpful for converting degree Celsius to Fahrenheit and Fahrenheit to degree Celsius. This is TF minus 32 upon 180 is equal to TC upon 100 degrees Celsius.